All right, well, we just finished 9-4, and hopefully did well on this little warm-up. It tested you on the kinds of things we practiced yesterday, too. Yesterday we just spent time practicing this stuff, too, right? We've just been multiplying fractions, or multiplying rational expressions, you might say, and now we want to turn our attention to adding and subtracting rational expressions. We'll also do something called complex fractions, but let's save that for a rainy day here. We'll save that for a little bit later. Adding and subtracting rational expressions will be a little bit of a chore just of itself. I think maybe most people in the world, when they hear that we're doing addition after multiplication, would think that seems to be the wrong order. But you know, if you have any experience at all with fractions, that adding fractions is actually harder, isn't it, than multiplying fractions? Okay, so we are doing it in the right order. I just want you to know. Okay, might sound easier, but it's definitely not. This is a little bit trickier. We're going to start with some nice, easy examples, though. So let's try these, and I should say ones that get steadily more difficult, as usual, right? We want to start with something that I think we can handle. This first example, for example, should remind you of adding the fractions 4/3 and 5/3. How would you do that? Can you do that? What would it be? 4/3 plus 5/3. This is not meant to be like a trick question, but it does require that you remember a little bit about how to add fractions.
9/3?
Yeah, isn't it 9/3? Right? You just, what do? What's the procedure if someone wants to tell me?
Find the common denominator, then add them at the top.
Yeah, and if there's already a common denominator, then we can just do what the second thing what you said was, and that's just add the numerators, right? Call it a day. And in fact, actually, in this situation, you might want to say that that's what? You might actually want to say that 4/3 plus 5/3 is 3, right? Let's go all the way. If we can simplify when we're done, we should simplify it, for sure. So with that in mind, can anyone tell me what this would equal? Do these have the same denominator? If so, then like, sweet. Let's just add the numerators. What do we get on the top? 4 plus 5 on top, just like up here, is 9 still, right? Nothing's changed at all. It's just instead of 3 in the bottom, we've got a 3x. But the denominators are still the same, and therefore we can just still add the numerators. The denominator, though, takes on the denominator of the original two fractions. What is 9 over 3x? Do we write that in a little bit more simple way? How would we do that? It'd be 3 over x, wouldn't it? That'd be how you'd simplify that? Okay, beautiful. Let's do b. It's subtraction, but you know, don't you, that when we're subtracting fractions, it's the same deal. The denominators have to be the same, don't they? Perfect. They already are. So what can we do? Over here. Talk to someone. Yeah, you don't no big tricks here yet. I mean, we are gonna throw some curveballs at you, but they're not here yet. Okay. You just combine the numerators. If the denominators are the same already, then like, sweet. Just add the numerators, or in this case, subtract them. Right. If we can do any simplification, we should. But I think here that's a pretty good way to leave it. All right, now we're getting into some prickly territory. How about C? What's the issue? What's the issue on C? Why can't we just add them right now, ready, go? Because they don't have the same denominator if we haven't said it already, right? So, how would you resolve that situation? Do you remember what you do when you have, we've got to find, well, we don't, least common multiple, yeah. We want to find we want this situation to be generated that we had up top, right? We want to have the same denominator. We might call it a common denominator, right? We would like these to have a common denominator so that we can add them. So what would be, you can call it the least common denominator. You can also call it the least common multiple, right? The LCM or LCD, same in fact, same thing, okay? So what is, now I want to make sure you're hearing me out. We're looking for a number, the smallest number you can think of, that 12 goes into evenly, and 3 divides into evenly. So can you think of a number that both 12 and 3 divide into perfectly? Yeah.
4.
No, so let me caution you. Whatever number you said, I'm going to say, your number divided by 12, and I better get an integer. Is 4 divided by 12 an integer? So we're looking for a number already, we know, that is at least 12. You with me on that? I think you have it backwards. You're maybe thinking of things that go into these numbers. I'm looking for a number that these two things go into. 36 works, but that's a common denominator. But actually better would be 12, actually. Yeah. Right? So actually 36 would work great. But let's do ourselves the favor of not getting big numbers in the picture if we don't have to. That's why it's called the least common denominator, right? Other common denominators might work. And how can we make both fractions have a denominator of 12? Well, this one already has it, but the second one we want to multiply by 4 over 4. Remember, you can't just arbitrarily multiply things by 4. But you may arbitrarily multiply things, anything you want, anytime you want, by 1. And isn't that what you're really doing? Let's just remind you. When you're multiplying by 4 over 4, that's all you're doing. Okay. And so the point is we don't want to at any point change the problem, right? This is still the same problem. If you were to reduce 4 over 12, you would still have 1/3. This is not a different problem. It's still the same thing. At every stage, this is equal, equal, equal. And then finally we can write what? Now we're in the situation we were in A and B. So what can we write?
4x over 12.
How about x plus 4 over 12? Is that an okay way to write it? Cool. All right, now D gets a little trickier yet. We have to think hard about this. We're looking for, maybe we shouldn't say a number. We're looking for a thing.
Couldn't you simplify C more?
No, not really. Sorry. But you're right to think about it. If we can simplify it, we should. You're right. So for D, let's maybe say we're not looking for a number. We're looking for a thing. How about we say? We're looking for a thing that 3x goes into evenly. And 8 goes into evenly. So make a suggestion. I don't know. Maybe forget the x for a second. Let's just think about the 3 and the 8. What's the smallest number we can think of that 3 and 8 both divide evenly into? Yeah, I think it's going to have to be 24, actually. Yeah? I think that's the best we can do. Sometimes it is just the product of the two numbers, isn't it? And that's okay. So 3 times 8 is 24. All right, so now 8 divides into 24, but 3x does not actually divide into 24 evenly. So what should we maybe make it? How about 24x? All right, so this is key, right? Over here we did it, but we didn't maybe write it. LCD is 12, right? As we're thinking about this problem. Over here, first thing we want to think about is what's the LCD, and we just identified it. It's 24x. All right, once we have that in mind, then now we need to make it happen, right? How do we get 24x to be the thing downstairs on this guy? Multiply by 8 over 8 to get 40 over 24x. And again, at any stage, we should be able to reduce this fraction and still have what we had before. We don't want to change the problem, that's for sure. And then over here, what do we have? What do we need to multiply by? 3x on top and 3x on the bottom, giving us 21x squared on top and 24x on the bottom. Again, if you were to reduce that fraction, we'd still have what we started with. So that's good. That's what we want. We don't want to change the problem. So I think we're ready now to add these together since they have the same denominator, and we get 40 plus 21x squared over 24x. And again, if we can simplify, we should, but there's not much we can do here. So that's cool. Anything else you want to say about that one? You remember the videos online too. The annotated PowerPoint is online.
It's not here,
You're lazier than that even though?
No, it's just hard to get to.
That's what I'm saying. You're lazier than Maddie. Okay.
No, I don't have internet Wi-Fi on.
All right. So any questions about this so far? Like I said, hopefully nice basic example, and then getting a little bit harder as we go. Just as a little interlude here, let me quiz you on some other least common denominators. If you saw the following two denominators, what would you say the least common denominator would be, or you could say the least common multiple? That is, we're looking for a number that both 10 and 15 evenly divide into. So help me out here. Logan, you think you got that one? Can you think of a number that both 10 divides evenly into and 15 divides evenly into?
30.
Yeah, and that's the smallest, I think, too, right? That's what we're looking for, really. Not just any number, because 150 might be a temptation, too, right? But let's not go there, right? 30 is much better, absolutely. We're not just looking for a common multiple, we're looking for the least common multiple. All right, beautiful. How about 8 and 12? Give me that one. How about Alan? Can you think of the smallest number you can think of that 8 goes into nicely and 12 goes into nicely? What's the smallest number we can think of? We're looking for a number that 8 goes into. Yeah, is that the smallest we can think of? I think 24 is the best. Okay. By the way, maybe there's a process. Maybe we can come up with like a better method than just doing this by inspection. I don't know. All right, how about 5x cubed and 10x squared? How about that one? How about Jason wants this one, I can tell. What do you think? Can you think of something that both of these will divide into evenly? Start with the numbers. 5 and 10. How about we start with? Yeah, you can do 50, but actually don't go too crazy. 50 will work, but can you think of something smaller that 5 and 10 both divide evenly into? Yeah, 10. And what about the variable part? We need an x. We need at least an x, but then this won't divide into that, will it? Oh, we need an x squared, right? Because then this will divide into that.
And it can still divide into the cube.
We actually need an x cubed, don't we? So that both, okay, and by the way, if you're wondering whether you got it right or not, just think, is there anything I can, what would I have to multiply this by to get this? What would you have to do? You'd multiply this by 2, and you'd get this. Hey, so that works. There better be something we can multiply this by to get, what would you have to multiply this by? X, right? And so in both cases, we're going to have something that works. That's great. Let's do one more here. How about 14x and 42x? Oh, no, excuse me. That was a giveaway, maybe. 21x squared or something. All right, how about that? Whew.
7.
We're looking for a number that both things divide into evenly. So we need something that 14x and 21x squared both divide into evenly.
7.
This is a tricky one. No, 14x doesn't divide evenly into the number 7.
Oh,
Into, right? No, 14x doesn't divide into 7x evenly.
it can't be lower than any of them.
Exactly. It's going to have to be at least as big as these things, right? Yeah, I think we need a 42, don't we? Okay. What else, though? If 14 and 21 both dividing.
Squared.
X squared, yeah. Will that work? All right. And how would you do that besides guesswork? Well, remember, I don't know how you were taught. How do you figure out that it's 42? How do you figure out the LCD of two numbers? 14 and 21. There are a couple of ways you could do it. Yeah. Carlos, go ahead. All right. Here's one way you could do it. There are a couple ways I might teach people, but you could just start writing down the multiples of 14 that you know. 14, and then add 14 to that is 28. Add 14 to that is 42. Add 14 to that is 56, right, etc. And down here, what's this? Add 21 each time. We get 42, 63, etc. So if there's, and actually we don't have to go very far in these lists. If you just want to stop as soon as you see in both lists the same number, then you're done, right? Here are the multiples of 14. Here are the multiples of 21. And 42 is a multiple of both, right? That's what we're looking for. Carlos, we're ready for you, sorry.
So I think I found a pattern. You like for all of them, you taking the highest number and multiplying it by 2, like 15 times 2 is 30.
Well, here's the highest number is 10.
Yeah, but in that case, you would multiply the one that has the highest power.
Maybe it's just because that's how I made them, right? Like, what's the least common multiple of like 10 and 25 or something. Okay. Oh, but see, I did it again. How about how about 9 and 21 or something. I don't know. How about that? What's the least common multiple?
I'm not sure about that.
All right. Well, we need 9 to go into it.
Yeah.
So, I mean, you can start listing the multiples of 9 if you want. I know I need 2 3s in my number, and I know I need a 7 also, don't I?
Yeah.
So that's how I'm going to come up with it. I think the answer is 63. Right? Doesn't 9 go into 63? And doesn't 21 go into 63?
Yeah.
Right? So does that follow your rule? I just want to dissuade you of the fact that, right? So I just happened to make up examples that were like that. You're right. Sorry. That's what happens when I make up examples on the fly. All right. Let's try another one here. Roll with me here. Okay, here we go. Again, look at this and realize, we need a common denominator, don't we? And we don't have one. So, before we go any further, let me make a suggestion. That you rewrite, you probably saw this coming, right? That you rewrite this first denominator as what? No. The denominator.
X squared minus 4 plus X plus
Yeah, like I said, maybe you saw this coming, but we're going to need to be doing some factoring here. Yeah. Can you think of how this factors, Anna? Makes sense? Yeah. That makes sense, Anna? Okay. X plus 2, X minus 2? Yeah. All right. Beautiful. All right, now let's ask the question again. These don't have common denominators, but how could you get one? What is the common denominator? What do these both have, and what do they need? Or
X plus
do you see it now? This denominator over here is x plus 2 times x minus 2, and this denominator is x plus 2. So I might say that this guy, couldn't we make this denominator look like this denominator by doing what? Yeah, we can multiply this by x minus 2, and if you multiply the bottom, we also need to multiply the top by x minus 2, okay? Top and bottom. So in doing that, you've just, even though we didn't say it, you've also just identified the LCD, right? Isn't the LCD x plus 2 x minus 2? Okay, that is our least common denominator. That's what both fractions have now, and we'll be able to combine them. So it'll be 4x plus 3 times x minus 2 on top of x plus 2x minus 2 on the bottom. And then we've done the addition. That was like the big power play. But now we should kind of clean up the numerator a little bit. What is 3 times x minus 2? That'd be 3x minus 6, right? I'm just keeping the denominator the same. And I'm going to clean up the numerator here. Last step may be 7x minus 6 over x plus 2x minus 2. So I think that's a good way to write it. We'll leave it that way. If you want to multiply the denominator out, you can, but you don't need to. Okay. If there's anything we can do to simplify this anymore, we should look. But I think that's pretty good right there. Questions, comments about that so far? All right, why don't you guys try this one as we close out here. See if we can get one more up there. I want you to do the same thing. What's the first thing you're doing? Follow my lead on the previous example. You might do what? So that second denominator. Factor, right? You know, the drill, you've seen now how useful factoring can be to us. I would factor that second denominator, and then what are you going to do? On this process here, we're going to try and get that denominator, both denominators to be the same somehow, right? So what do we need to do? Help me out. Multiply what? By this first fraction over here, right? We need to have this be x plus 1 times x over x plus 1 times x minus 1. And then now you can just add the top and bottom, right? Up to here we have x squared plus x minus 3x all over x plus 1, x minus 1. Combining like terms up top, we get x squared minus 2x over, you could write x squared minus 1 if you want on the bottom, that'd be fine, whatever. Okay? So we'll get a little crazier, but not too much. I mean, you have now the general idea of how to add rational expressions. If it's still uncomfortable in your mind, like that would be completely fine. We just started talking about it only 20 minutes ago. So, we'll clean up tomorrow. We'll spend a couple days on this. It's not a big deal.